Hello, I'm Peter Heinrich. I'm a developer evangelist, as he mentioned, and I want to thank you for joining me today. I want to start by saying that this session, maybe contrary to the title, is not going to be a crash course on every Appstore API that we make available or every library that we offer in our development program. My goal is really just to show how game developers can think of Amazon Appstore and Unity as complementary technologies. So Unity has shot to the front of the pack when it comes to cross-platform game development, and Amazon Appstore is supportive of the Unity framework / engine. So laying out our agenda for today, I'll talk a little bit about some of the APIs that we offer, the ones that at least you can use alongside Unity when you're writing mobile games, and then I'll briefly talk about what it takes to get access to those APIs. It's very straightforward. I'll walk through setting up the Unity plugins and handling events, and I think you'll see from the code, there will be a little bit of code, don't be too scared, it's not too bad, that the integration is actually pretty dang easy. So finally, I'll take a look at Unity's built-in support for in-app purchasing on the Amazon App Store. So let's dive in. My animation's very slow, but the Amazon App Store has a number of ways in which we try to help you improve your game's player experience, your user retention, monetization, everything related to revenue-generating opportunities. And our guiding principle is pretty straightforward. Amazon's founder, who I'm sure you know is Jeff Bezos, laid it out in just 7 words, and they actually apply to all areas of our business, whether it's web services or retail or on-demand or digital, it doesn't matter. This principle applies regardless of how we define quote-unquote customer in each of those areas. So for App Store, our customers include users, obviously, for whom we're a means to get the content that they want on their Amazon devices like Fire tablets and Fire TVs. But they also include developers on the other side of that equation, right? The ones that are trying to get their work into the hands of the public. And that means that the App Store has 2 very different kinds of customer, each of which requires us to work backwards in a slightly different way. But there is this unified vision across both, though. We want to delight customers by connecting them with the content and the experiences that they want or that we might think they want. And this obviously serves the creators as well as the consumers. So from the consumer's perspective, the most direct manifestation of this is actually the App Store itself, right, which comes pre-installed on all of the Amazon devices, and it can actually be side-loaded on any Android device. It's an app marketplace that also offers features and benefits unique to Amazon, like Amazon Coins, which is a virtual currency. And I promise I'm not going to shill too much for the whole talk, but I thought I'd lay out the basics. And we also offer Amazon Underground, which is a program allowing customers to install and use freemium or premium apps at literally no cost forever. So on the developer side, there are a bunch of services that we provide to simplify and lighten the burden of development, making it easy to add functionality and features that you would otherwise have to code yourself. So this is in addition to programs like Amazon Coins that I just mentioned, and which, by the way, is totally transparent to developers, right? You don't have to do anything to benefit or make changes to your code to benefit from the enhanced customer engagement that comes with that virtual currency. And Amazon Underground is another example that serves the developer as well as the customer, providing this alternative monetization model that can be actually better in some cases than typical premium or freemium apps in the right circumstances. And for several of these APIs, we actually provide direct Unity support. And that comes in the form of downloadable plugins. So using them is as simple as including our plugin as you would any other third-party plugin in your Unity app. And we have Unity plugins for in-app purchasing, IP, mobile ads, Game Circle, which includes achievements and leaderboards and WhisperSync for games so you can sync data across multiple devices, and Amazon Fling, which allows you to create these enhanced multi-screen experiences. So to download these Unity plugins, and before you can use them from within your mobile app or game, you need to register as an Amazon developer. This is completely free, and if you're already an Amazon customer, turns out you're actually more than halfway there, since mostly we just need your name, your address, and your email. So the way you do this, you kick things off by going to our developer portal, developer.amazon.com, and it's a one-stop clearinghouse of everything you need to develop for Amazon devices or use the Appstore services. So you'll find links to documentation and sample code and payment and analytics dashboards, and you can find app publishing tools, you can get videos, everything you need to do, everything you need to develop for Amazon devices, and actually use any of these services on Android. You'll also find a bunch of resources like marketing and promotion documentation, guides based on our experience as an app publisher that we think will get you a little bit of an advantage in a very, very crowded marketplace. So once there, you can sign in with your regular Amazon account, and you're good to go. If you have an account already, then basically it'll just drop you directly into the screen where you have to provide some basic profile information like your name, your address, and email, and then we'll ask you to agree to our app distribution and services agreement. It's all pretty standard fare. None of this legalese will be unfamiliar if you've ever published a mobile app on any other app store like Google Play or iTunes, and I'm sure the terms are very similar, so no surprises. We'll also collect a little bit of information about your business for future payments, namely, will you be collecting any? And if so, how do we pay you? And again, nothing too difficult or surprising here. The trickiest part, actually, and I get a lot of questions about this, is just looking up your bank info so that we know where to send the revenue that you generate in your game. And if you will be generating revenue through your app, then once again, I need you to provide a little bit of extra information besides the banking info. We need to ask for this information in order to complete some government paperwork. But again, I only mention this because I get asked about it so frequently, and we have to collect the information, but hopefully it's, practically speaking, not too onerous. It's not really particularly difficult, and seldom does this step actually add more than 1 or 2 minutes to the whole process. Once you do it, you never have to do it again, no matter how many apps or games you publish using this account. And that's it as far as the sign-up goes. So now you have full access to our developer portal, including all the documentation, all the downloads, and we have a bunch of SDK files and code samples there, as I mentioned, so you can use this handy-dandy bit.ly link at the top, bit.ly/appstore.sdk, to access them all directly. And then once you reach this page, just scroll down, you'll find the links to the files you want. You'll notice that there are also iOS resources, as well as the ones that you would obviously expect to find for Android and Fire OS. And that's because some of our services, like Amazon Mobile Ads, log in with Amazon and Amazon Cloud Drive, for example, can actually be used with iOS apps as well as Android platforms. So we're not strictly Android only when it comes to some of these services. Okay, so the hard part's out of the way. Let's look at a real live service and see what it takes to actually access it from Unity. We'll start with Amazon Mobile Ads. They support a very popular and common monetization model just about everybody in the industry knows about. Sorry, I'm distracted. I keep seeing this flashing. Has that been doing that the whole time? Oh, okay. Well, anyway, most people are familiar with mobile ads or have used them, even if they haven't, or they're familiar with them even if they haven't used them. So the very basics, the Amazon Mobile Ads API is an in-app display advertising solution, similar to others you may have used. It allows you to monetize mobile apps and games across platforms, including phones and tablets. And this service is one of those that works across Android, iOS, and Fire OS. And it actually offers really great revenue potential because we pay you based on ad impressions instead of the more typical ad clicks. And the ads themselves are generally pretty relevant. They're high quality, either for Amazon itself or for high quality brands. So this program is available in a bunch of different geographic regions, including the US, UK, Germany. Well, you can see all the flags down there at the bottom. And you, as a developer, can use the service regardless of where you're located. So you're not limited to those geographies. Those are just the regions where Amazon mobile ads are actually served. So as long as you have customers in those areas, the Amazon mobile ad network is a great option. So the mobile ads API supports a few basic ad types. Static banners, obviously they're HTML web views that typically open an in-game browser or a native browser or an Android intent. You have rich media expandable banners, static interstitials, which are full-page ads, usually appear in a transition point in the game, usually something like moving between levels. You have a modeless interstitial, which is a full-screen ad that can be embedded inside an Android container view, provided it's large enough, which is useful if you have image carousels, for instance, and you want to interleave ads in between. And finally, you have rich media interstitials, which combine many of these features at once, allowing for some rich interactivity and enabling click-to-play video. So now that we know a little bit more about what the service offers, how do we go about using those features in our Unity app? And the first step is simply to add the correct plugin to your Unity project. In your Unity development environment, you just open the project tab, right-click on the assets folder, bring up the context menu, and then import package. And that's all there is to it. We've already downloaded the SDK, let's say, and so we just need to navigate to the subdirectory where we unpacked it. Look for the file with the Unity package extension. In this case, for mobile ads, it's the Amazon mobile ads.unity package. That's the file you want. And then once you click open, Unity will show the list of all the files that it intends to import. And the reason it does that is because it wants to give you a chance to check for conflicts with files that are already in your project. And we try to minimize the likelihood of this happening by naming the files, in an intelligent way so that we don't have conflicts. But of course, there's no foolproof system, so it's possible that there may be some conflict. And if one does exist, it's really up to you as a developer to figure out what all the local changes are, save them off in a different place, and then merge them back in manually after you've imported. And this is just a side effect of the way Unity handles plugins. So, like I said, we try to minimize the chances, but there is always a slim possibility that there will be a clash. Then once complete, your project folder may look something like this. You see that the Amazon Mobile Ads plugin is listed under the Assets Plugins Amazon folder alongside the Android and the iOS folders that contain the native code to integrate with the SDK. Now, with some services, and Amazon Mobile Ad Network falls into this category, there is going to be an application key that the service uses to enable access and tie usage back to your specific game. So when you publish games on the Amazon Appstore, just as on other app stores, they'll appear in your management console, allowing you to add product listing assets like screenshots and videos and the description, that kind of thing. And you'll also be able to review the application keys that we generate for your game. So for instance, to see the key that enables the mobile ads service in your game, in this case, you'll go to the app management page and click through the mobile ads link. And your game won't automatically have access to the Amazon Mobile Ad Network. The first time you click through this link, you'll basically be saying, yes, I want to use mobile ads in my game, please turn on access, and then you just click submit, save the setting, and after this, the service knows that it can serve ads to your game, and it will generate a unique ID that you can use to identify it as a valid client. So in my example here, the Mobile Ad Network has created this unique identifier associated with my Android game and identifies it as a valid client, and it will expect that I supply this value whenever I make a call to the service from within the app. And you note that there will be a separate, different ID generated for the iOS version of my game, if any, and if I wanted to do that, I could set that up here as well. The service can then differentiate between the same game running on different platforms. So let's take a look at some code. This is the Unity script to initialize our connection to the Amazon mobile ad network using the SDK we imported from the plugin. And so where you put this code is really up to you, whether you have a dedicated game object or you roll this into some special initialization module, wherever it ends up. You just need to note that I created this public string containing my mobile ad application key. Actually, I created two, one for Android, one for iOS, separate one. And then down below, you can see how I used preprocessor directives to choose the correct string based on the platform where my game is actually running. And once I have the key, I can pass it to the SDK object I created that holds the API endpoints for the service. And since we're good programmers and we have a healthy paranoia when it comes to testing, we're going to enable testing and logging for our calls to the mobile ads API. And this boils down to retrieving the interface again. This is the Amazon mobile ads implementation instance, and then setting the current state of its testing and logging members. And it's especially important if you yourself are located outside of all the supported geographies that I mentioned before. Those are the US, the UK, Germany, France, Spain, Italy, and Japan, since if you call the API and you're not in testing mode and you happen to be located in one of those, in some other country besides one of those 7, then the service will never actually display anything. And then on Android, before we can actually create a test ad, which is what we're building up to, we'll need to make sure that our manifest includes a few key features. So first, we need to make sure that it requests the right permissions to enable access to the service, which namely in this case would be internet, access network state, access Wi-Fi state. And then second, we need to add the ad activity to the manifest. And in the interest of time, I'm not going to go into the detail about the corresponding steps on iOS, but you can find all the information that you want about that on our developer portal. So now that we've turned on debugging, we've turned on logging, we've made sure that our app has the correct permissions via the manifest file. Oh, and we also explicitly declared the ads activity. We can try creating and displaying a test ad. And again, it's up to you where you want to put this code. You can put it on a button, since this is a test. Click a button in your UI, pop up an ad, maybe attach it to some other UI element. Regardless, the goal of this method is to create and display a floating ad that's docked to the top of the screen and centered. So in this case, we'll use the helper class provided by the SDK called placement, and it allows us to specify parameters related to ad size and positioning. And next, we'll call the mobile ad service to actually create the ad, having the correct placement. And then finally, we'll tell the service that we actually want it to return us something from its ad inventory and then display it. Remember, if you're not in one of the supported geographies and you haven't enabled testing, you will never get anything back from the service. So be sure to turn on testing if you're working from outside of those regions. But since we are in a supported geography, at least for this demonstration, and I happen to turn on testing as well, it does work, and here's what we get. We get a simple banner ad docked and centered at the top of the screen, which in this case happens to be in landscape mode. The SDK will automatically take care of rotating the ad for you based on the orientation of your device. And you can see it's pretty straightforward to create an ad object, set up some parameters, initiate the call to retrieve the content, and then throw it up on the screen. And you can do that regardless of where you're located, just to reiterate. And the mobile ads SDK actually exposes quite a bit more functionality and configuration that's all supported directly by the by the plugin for Unity. So now we know how to import a Unity plugin into our project. We know how to use it to call functions on a remote service. Let's look at the process for going in the opposite direction. That is, how does a remote service communicate with our application through Unity? Well, as you may have guessed from the slide, it's event handlers. So returning to our mobile ads example, we can define functions that the service will call whenever something interesting happens or changes occur. So here's an example of some code that we want called whenever the mobile ad service successfully loads an ad in response to a request from us. This way your game objects will be notified when ad content actually loads, so you can, for example, pause game music, for instance, while you are displaying the ad, or you can take some other action. But we also want to provide a function that handles request failures. So if the ad doesn't load, you do something else, like maybe you have a mitigation service that allows you to rotate through several different ad providers and try to get that ad spot filled by somebody else besides Amazon. Totally fine. These callback functions are basically event handlers, and all you need to do to implement them is fill in the function and then register them with the mobile ads wrapper that you instantiated at startup. And that's the pattern that you apply pretty much anytime you want to incorporate an Amazon API into your Unity app. It boils down to 4 basic steps, not all of which are necessary every time. But first, you obtain a handle to the implementation object, which is defined in the SDK. That acts as your interface to the service. Next, you prepare any parameters that you may need to pass it for the API to operate on, or that will modify its behavior. And as I mentioned, some APIs take no parameters, so sometimes this step isn't even necessary. Third, in the cases where a result won't be returned immediately, you need to define a callback function to process it when it does become available. And then finally, just go ahead and call the API member through the implementation object, passing in the parameters you initialized. This is the basic outline for calling any Amazon API if there's a Unity plugin for the corresponding service. So let's walk through one more quick example before moving on to Unity's built-in support for Amazon Appstore. The Amazon Fling service is a toolkit. It works on iOS, Android, Fire OS, and it allows you to build multi-screen experiences for Fire TV devices, including Fire TV and Fire TV Stick. So you can send media from your mobile game, regardless of platform, to be rendered on a Fire TV or Fire TV Stick, and the SDK allows your mobile game and destination device to communicate back and forth in both directions. So it's possible to create cool, engaging second screen experiences, or a game that has 2 different kinds of UI depending on what kind of device you're on. So working with the Fling SDK from Unity is substantially the same as we saw for mobile ads, although in this case, since there's no application key that you need to keep track of and pass in when the SDK is initialized, it's actually slightly easier to use. So you just somewhere include the initialization code. That still has to take place. And the SDK will give you back an implementation object that you can use to execute API calls. Now it happens that Fling is actually heavily asynchronous compared to mobile ads, but that's not a problem for us because we saw how to create callback functions. We already know that there's nothing to it, and just like mobile ads, the Fling SDK has special APIs that allow us to set specific event handlers. We just need to make sure that we define the functions somewhere and pass in the names and make sure that they're accessible. So we saw that how event handlers work. The Fling SDK supports them. We just need to tell it what to do in certain circumstances. For instance, letting us know about potential target devices where we can send media or control the volume or pause or play, etc. We can tell the SDK to start looking for targets, and then it will alert us whenever it discovers one. Maybe we then take the opportunity to update a list of potential targets for the user that they can select from. Similarly, if a device gets turned off or moves out of range, then we may want to be notified that it's no longer a valid target. So the Unity plugin that we make available actually supports both sides of the Fling SDK, which means you can use it to create an app that accepts flinged content, we'll call it that, or a target, which is a controller, like an app or a game that can initiate playback or choose the content. And then, like mobile ads, there are a few modifications that you have to make to your manifest file on Android to enable this Fling functionality. And again, basically this comes down to just adding the correct networking permissions. If you happen to be deploying on Fire OS, which is the Amazon Fire Tablet OS, it's also turns out that there's no need to actually link in the Whisper Play jar file, for instance, because that's already included in the OS. On iOS, it's slightly more involved, so I won't go down that rabbit hole, but instead I'll direct your attention to the other bit.ly link at the bottom of the screen. It'll take you to everything you ever wanted to know about Fling and how to incorporate it into your iOS and Android apps. Okay, with that, we have a basic understanding, I think, of how to integrate Amazon Appstore services in Unity. It's pretty straightforward, at least through the plugins that we offer. And really, a basic understanding is all we need because there's just not much to it. But let's look at one more common example. This is one actually for a service that maybe people would consider critical. We're going to explore the interface from a slightly different angle, however. So if you've developed a mobile game in the last 5 years, or maybe even longer, 10 years, you've implemented in-app purchasing, or you've done a bunch of soul searching about whether you should implement in-app purchasing if you haven't done it yourself. Of course, a big part of Amazon is selling, that is connecting customers with the products they want, whether those are physical or digital. So naturally, we support in-app purchase, and we provide an IAP Unity plugin to simplify that integration. And there are a lot of benefits to using our plugin, including direct support for Amazon's one-click, the virtual currency I mentioned earlier, Amazon coins, and detailed metrics and reporting. But in some cases, maybe your needs are more cross-platform, or you don't have the resources to target multiple app stores. And for those situations, you may choose Unity's built-in support for Amazon Appstore, which features a more cross-platform aspect at the expense of slightly less advanced functionality. So you can always come back to our plugin if desired. And in fact, we do have a recent blog series on how you would do that, how you would use it. So you can just follow this bit.ly, or if you just search for IAP Unity on our blog, you'll find it. For our purposes today, though, we're going to explore how Unity supports Amazon IAP out of the box. And the first step is to associate a project ID with your Unity game in order to turn on support for Unity services. Just as some Amazon services require an app key to authenticate and authorize these service calls, Unity uses something similar. They call it a project ID in order to identify their valid clients. It's just an online identifier that you generate for each game that you want to connect to Unity services, and you have to specify an organization to associate with your project ID. So when you first sign into Unity, it automatically creates a default organization. You're welcome to use that one, or if you develop under several organizations, you can specify at this time, as you're setting up the project ID, which of those organizations you'd like to use. And then you need to provide the project name itself. And you can generate this thing on their website. You can generate it from inside the editor, which is what I'm showing here. Just go to the services window and click through to generate this ID. Now, once you select your organization and the Unity project for which you'd like to enable services, you can find the in-app purchasing service and turn it on. And Unity's built-in IAP actually supports several different app stores, not just Amazon, of course. And as I mentioned, sometimes it's convenient to forego some advanced store features in favor of quick integration or a simplified build process. Recently, Unity introduced an even more streamlined way to incorporate cross-platform IAP in your game. So we're going to explore that approach a little bit. You can enable it by clicking this checkbox, which is, I think it just says Simplify Cross-Platform IAP. And then you'll come back and actually have to answer a few questions about COPPA, right? So COPPA is the Child Online Privacy Protection Act, and it's designed to spell out the rules governing online collection of personal data from children under 13. Well, it turns out that in Unity, if you turn on IAP, it automatically turns on analytics, which then leads to this this collection data, this data collection question, right? So if this is the first time you've turned on IAP for this project, then you'll need to specify your approach and whether or not you actually are COPPA compliant. Once COPPA is out of the way and IAP has been enabled, then you just need to ensure that Unity's IAP package is actually included in your game project. And this is substantially the same as importing the plugin for mobile ads or IAP in that case. Although Unity does make it extremely simple by providing a single button to import everything that you need. And this will be necessary regardless of the App Store or app stores that you choose to use with this service, whichever one you intend to target. Now you may see a dialog pop up prompting you to authorize installation of the Unity IAP package. Just click Install Now. And then you'll see a bunch of new files in your project. So if you haven't already done so, Unity will create a plugins folder for you. It'll copy all of the IAP assets into it. And these are the files that it needs in order to enable the Unity purchasing API that you're going to be using. Going back to the Services tab, you should now see the in-app purchasing service shows as enabled. And as I mentioned earlier, the analytics service will also be enabled automatically in response to turning it on. Now comes the highly involved technical process of selecting the Amazon App Store to be the target for IAP events in your game. Actually, I'm just kidding. You basically just choose something from the menu and you're pretty much done. Of course, this assumes that you've actually set up an Android project in Unity when you started, since Amazon, I don't know how many people knew to begin with, is an Android target. So now we're ready to give Unity's simplified IAP approach a try. They call it Codeless IP, and it certainly reduces the amount of code that you have to kind of whip up from scratch, at least to support in-app purchasing in your game. It doesn't eliminate the code completely, but it pares everything down to the point where it feels practically code-free, which is why I say without coding mostly. Instead of initializing the IAP service explicitly in a script somewhere, building your catalog in code, then writing more code to call IAP functions in response to player actions, for instance, Codeless IP basically relies on you using the editor to define your catalog as you would any other graphical component. And it also provides special UI elements that allow players to initiate IAP actions directly. So rather than through calls that you make, you just add IAP buttons to your game, and then when the player clicks on them, they automatically initiate the IAP calls on your behalf. The first step is to create one of those special IAP UI elements that I just mentioned. And you do that by going to the window menu and eventually checking the Create IAP button. Then once we do, we get a simple object with a few specialized components. And we'll come back to them in a minute, but first let's look at the IAP catalog that will be used with these buttons. So if this is the first time clicking through, we see a simple window with a single blank item, no ID. It starts off as a consumable, and now's our chance to fill in the unique item identifier. Let's say we have a space game with upgradable ships. We want to define a new Hyperion-class battlecruiser. It'll be an entitlement, so we'll mark it as non-consumable. We'll make it inexpensive, 99 cents, let's say, and there'll be other upgrades later at higher price points. But for now, we'll just create this single item. Eventually, we define all of our IPs in this dialog, rather than making explicit calls to create them in code, which may be what most people are used to. The next step is to connect our button to some purchase action. And this is one reason I describe this codeless IP as mostly codeless, because you still have to have a function somewhere that actually entitles the player or otherwise registers the purchase, increases the amount of consumable items or whatever it is. There are actually two purchase type events that you should be handling. The purchase success and the purchase failure. And you specify handlers for each of these by clicking the little plus below each list. So again, not super codey, but still, I mean, you've got an editor window to do this, but you still end up having to produce some kind of callbacks. And then it's up to you to point each callback at an object that can actually handle that. In this case, I created a purchase script that I attached to a button, and that script has two basic methods. It has purchase, purchase and fail to purchase. And this is a peek at what that script might look like before I actually add any useful code. The purchase method I've defined here takes a product object as a parameter defined in the Unity purchasing package. And similarly, for the fail to purchase method, you get a product parameter, although in this case you also get an error code indicating why the purchase failed. And it's important that the methods that you come up with, or the functions that you define here, have these specific signatures, otherwise they won't be accessible from the previous dialog, which is kind of what you'd expect.
We have a break between speakers.
So the benefit of handling IAP in this way, as I mentioned, is that very little code is needed. You just saw all the code that was necessary, or at least its outline. But notably absent is any kind of extensive system initialization or specialized error handling, as well as any direct calls to the IAP system service itself. Even cross-platform or platform-agnostic calls are unnecessary. So it works primarily from configuration of the UI elements and the underlying IAP catalog that you build in the editor as opposed to the code. So the result is this rapid development with common components and less debugging. And it's a trade-off. It's a trade-off between coding and configuration. So it allows you to make the decision about where you'd rather spend your time. So in my case, I can take the IAP button that I just created, drop it into my game, wherever it makes sense. And then when a player clicks it, the system takes over and handles initializing the service, if necessary, calling through to the back end, which essentially means communicating with the target Appstore, initiating the purchase, confirming the success. And then my game is left with the relatively simple task of just registering the effect of the sale, right? That's just increasing a consumable count or turning on access to some entitlement. So perhaps the Gorlak ship, for instance. But what does the actual IAP UI look like? Well, it's not very pretty, but that's just because this is, what's provided as the default. It's really up to you as the developer. You get this basic interface that you can use during development or in an emergency, I suppose, but it's really meant to be replaced. And the point is that you have the complete freedom with this system to do that. The IAP system can be an extension of your game's look and feel if you want it to be or not. Again, it's a trade-off. The time that you would have spent coding, you can now dedicate to fine-tuning the interface if that's what you'd rather do. And a quick check shows that when the player clicks buy, our handler actually gets called. Similarly, if they choose cancel, our fail to purchase method is invoked. So very straightforward. One very important item to note, regardless of how the client-side system is configured or executed, the backing Appstore still needs to know about the items that you intend to sell in the game. That is, whether you build the catalog on the client using code or through Unity's codeless approach, those items must still correspond to real products that the Appstore of record actually knows about. Right? It's important that the product IDs you choose match in both places, because the game itself, that is between the game itself and the store where they're actually purchased. So on the Amazon App Store, you do this through our developer portal. Just as for other mobile publishers, the first step is to tell us about your game. You create a submission entry for it, and then that's where we'll keep track of all the IP items that you want to hang on it. We really only need the basics to get started. Eventually, of course, you're going to go through and you're going to fill in data on all these tabs. But just to illustrate catalog setup, we can skip to this in-app items link. And then we can start adding in-app items by type. So in our case, for our ship upgrade example, we're going to add an entitlement, which is basically just an item that sticks around after purchase. It can be reused over and over again. It doesn't get consumed after you use it in the game. And then it's just a matter of supplying the same data to Amazon App Store that we use to configure the item in the game. The SKU, in this case, corresponds to the ID used by Unity, and that's what connects the in-game item to the store representation of the product. Remember, the store is the thing that actually executes the sale. So you want to make sure that your game is communicating to the store correctly. This is also where we establish the item pricing. Obviously the Amazon App Store allows for selling all over the world. So for several of these, this includes giving customers the ability to pay in their own local currency. And when you price your item on Amazon, you have the option of setting the local price in those places or allowing us to set the price in those geographies for you. Title and description, again, we just use the exact same values that we use to configure the IP catalog in Unity. And technically, these fields don't have to match across environments like the SKU does, but it's simple enough to make them the same, and it avoids confusion if the in-app item is ever displayed apart from the game itself. So for example, if Amazon were to make them available through its retail website or something like that. Same goes for the imagery that we associate with the item. The App Store, just like every other App Store, requires us to upload a small and large version of some artwork to represent the product. It's a good idea to use the same image as we do in the game, just because even though technically they don't have to match, it's just a good practice to avoid confusion in the future. And that's all there is to the IP creation on Amazon App Store. Now, when a player clicks our Upgrade Ship button and Unity's purchasing system passes the purchase request through to Amazon, our App Store will have all the data it needs about the desired product and will be able to effect the sale. So what do we take away from all this? Well, I hope, above all, that I've made it clear just how little effort is involved in integrating Amazon APIs in your Unity games. The basic pattern isn't complicated, but it opens up several useful and cross-platform services for easy inclusion in your games. And all you need to do is register as an Amazon developer, check out our developer portal for free, peruse the features and functionality, look at the services that we make available, and then use the Unity plugins on our developer portal to connect your game to the service you need. Of course, the last step is probably the most important, just publishing on the store. And in the case of Unity's new Codeless IP, you may even be able to avoid most of the coding typically associated with creating these in-app purchases. So why publish on Amazon in the first place? It's the best way to reach our customers, millions of game players on Amazon devices, and you can reach them where they live, in countries and territories all over the world, 236, I think, at the last count. And as Mike pointed out earlier, the barrier to entry is low. A huge proportion of the apps and Android apps that we've tested just work on our platform with absolutely no changes to the code. And it turns out that our customers are actually more likely to purchase than on just about any other app store. We have more customers that spend more money in-game. And that's it for me. I really appreciate you sitting through this, and please take a moment, if you will, to fill out our survey for yet another chance to win some fabulous prizes and clothing. And I think Mike is coming up here to reiterate that point. Thanks very much.
Peter, thank you. I really appreciate it.